Hello everybody, Mr. Rubo here, and today we're going to do topic 1.3, rates of change in linear and quadratic functions. So similar to last topic, but this one is more specific to linear and then quadratics. This video is going to focus on linear though. So we're going to first talk linear functions. So for any linear function, the average rate of change over any length input value interval is constant, meaning it does not change. It is the same whether you look at from point at x equals 1 to point x equals 7, or from point -1000 to point 2. You'd find the average rate of change from those intervals, and you will see that they will be the same for that linear function. So they could be 4, could be both 4, both 7, both 22 sevenths, right? But we often think of this as just the slope of the line, okay? So that's kind of the basics. Let's do a quick example here. So we have this table, and they want us to explain why the function is not a linear function. Kind of two methods to go here. One is kind of using our table and looking at the differences or what's the pattern in both the y's and the x's. So if you look at the y's, you'll notice I'm adding 3 every time. So it's got a nice constant change. But when I go to the x's, I add 1 from one point to the next. I would add 2, and then I add 4. Now that is not constant. So they're not both constant, which actually right there tells us it's not linear. But we also can show it using our slopes, okay? So if we wanted to do the slope method, and I guess I should also point out, this only shows us that it's not linear because they're both not constant. One was constant, one was not constant. If they both were not constant, we'd have to still do the slope. So sometimes you might want to just jump right to the slope anyways. So what I'm going to do is I'm going to choose 2 points. It can be any 2 points. So I'm going to choose the first 2, and I'm going to find their slope, okay? So m for slope, y2 minus y1, x2 minus x1. Hey, I get 3 for the change in y, and I get 1 for the change in x. That's crazy. It's like we already did that. So the slope here is 3. If I then go, let's say, the second point to the third point. So again, I could have chosen any 2 points. I could have done the first to the third, first to the fourth, second to the fourth, like any combination as long as it's not the first and the second, because I've already done that. It doesn't matter. I'm going to go ahead and do the slope formula. So y2 minus y1, x2 minus x1, simplify, and you'll notice, we get 3 halves, which I don't need an equal sign after there, and we get 3. Those are not the same, right? So we can clearly see it is not constant. Sorry about that. There we go. So they're not constant. So we can now give a more concise answer. And I'm going to type this so it's not as messy. So we could say f of x, it cannot be linear. Ooh, helps if I type all the words. Since the average rate of change is not constant. Okay, so again, constant meaning it has to be the same numbers. 3 and 3 halves are definitely not the same numbers, so they are not constant. All right, that's it for this video. So thanks for watching and have a great day.